Welcome back. Today's project is going to be a relatively short one. I just picked up this Wohlhaupter UPA-2 boring and facing head off eBay. Basically, I traded it. I had a UPA-4S5. I don't know what I was thinking when I bought it. Here's a picture of what it looks like with my hand for comparison. There's no way in hell my tiny little mill would be able to swing that without shaking itself to bits. So sold that, used the money from it to buy this, which is much more suitably sized. The auction for this didn't really show, and I was kind of hoping that this would have the removable shank. Some of them did. This one is not. So this has a Morse Taper 2 shank, which is incompatible with my mill anyway. It has an R8 collet system. But beyond that, if you've watched any of my other videos, you'll know I like to have repeatable tooling. And on the mill, I do that via these TTS holders. This is my normal boring head with the TTS holder on it. And what makes these repeatable is all the holders have a 3/4 inch shank. And this face here registers against the nose of the spindle. And every tool is like that. So they all have repeatable tool heights. So in order to get that on this, I was originally thinking about cutting this shank off and remaking it somehow so that it was compatible with the TTS system. I don't necessarily want to do that. So I got an idea from another YouTuber. I'll post a link to the video in the description, where he basically takes one of these MT2 to MT3 adapters and machines it down to a straight shank so that he can use it in his mill. So I'm going to do basically the same thing, but I'm not going to machine it all the way. I'm actually going to leave a lip at the bottom here, probably about 1/8 of an inch thick. And Tormach makes these little TTS adapters for if you have any other 3/4 inch shank tooling that doesn't have this on it. I mean, you can see. So I'm going to machine this down to 3/4 of an inch, leave the little lip, and then press this onto it. And that'll give me the registration face. And then all I'll do is cut this down just a little bit proud of the end of the shaft, or the end of this, and then that's a M10 by 1.5 thread inside, and I'll just make a small bolt to hold this down on so it doesn't go anywhere. So I've got the 4-jaw chuck on the lathe. I'm going to chuck up this end here and just put a live center in this side and dial it in and get to cutting. So I'll meet you over at the lathe. All right, over at the lathe, I've got the 4-jaw set to hold the tang on this. So go ahead and put it in. And just use the live center to hold it. I'll go ahead and dial this in. So to dial something in on a 4-jaw, you can see when the needle swings clockwise, it means the piece is moving towards the indicator. I mean, you can see the run out there. So you want to find the low jaw, which is that one. Loosen it a bit, and then tighten its opposite. You can see that I moved it just a little bit. And I'll usually do 2 jaws at a time instead of trying to work all 4 It's easier just to get one side set and then work on the other two. At least to get everything close. Okay, we're going to see we're within a couple of thou there. So we'll do the other two jaws. That's the low. Okay, now everything's within 4 or 5 thou. Instead of loosening the lows, you can start tightening the highs. So that's the high jaw there. Also high. Oop. Sorry. High jaw. We want to get this as close as we can. It's not super critical for something, you know, for a boring head, which turns offset anyway. But no harm in being precise about it. That's within half a thou. I think that'll be good enough for today's application. Gear. So I got on a bit of a tangent. It was cutting a ridiculous taper, so I had to realign the tailstock. And any of you that have a mini lathe like this know what a joy that is. I mean, I got it set, and this is one of those things I don't know why I didn't do years ago. I got the quick chain, or the cam lock tailstock mod from Little Machine Shop, and it works great, but the little tiny lever that the stock tailstock comes, or that the kit comes with, leaves a lot to be desired. And so I took just a couple minutes, some random stock I had sitting in the bin, put an M8 thread on either end of it and put a little kink in the middle, and dear God, the quality of life increase here is just awesome. If you have a mini lathe with the cam lock tailstock and this rinky-dink short little handle, cannot recommend this enough. I cannot believe I didn't do this years ago. So anyway, back to the machining. So unfortunately, this is all that's left of the video file from this section of the machining. I don't know what happened, it got corrupted somehow, but anyway, I wasn't getting good results with the workpiece chucked up the other way. So what I ended up doing, the piece that's held in the copper soft jaws there is actually my tailstock alignment bar. And it's a Morse Taper 2. So I decided to go ahead and chuck it up with the copper soft jaws to protect the measuring surface. And then the other end of the adapter sleeve has a center in it. So I ended up dialing it in the forejaw this way and got much better results. You can even kind of see where the color kind of changes at an angle there in the middle of the workpiece, that it wasn't turning correctly the other way. It was off center. So anyway, I turned this down to the appropriate diameter, 3/4 of an inch, 0.750, and then took it out of the lathe and just kind of eyeballed where to cut it, and then did so. Alright, I just whacked that off with a hacksaw. I'm going to go ahead and just face this down to length. It'd just be a little bit longer. Leave just a little bit of that cutout right there. It should be long enough. Okay. Apparently we need to affix that better to the taper. I think that should be good. Chamfer it. Alright, that should be good enough. I'll go ahead and deburr out the rest of the way and bring you back for making the bolt for it. Alright, I figured rather than go crazy and make a bolt and thread it and mill it and all that, I got enough Saturn engine hardware to choke a donkey. So might as well just use the hardware I've got. I'm going to go ahead and clean it up. Got to turn this flange down a little bit. But yeah, might as well make things easy. Might as well have it in gear. Well, I think that'll do nicely. All right. Let's go assemble. All right. Well, the socket would only get that far. I guess I'll just do the rest in the mill. Alright, all the pieces, the TTS adapter collar pressed onto the sleeve, wiped out that taper, wiped off this one, slap that on. Okay, secure that. One TTS Wohlhaupter UPA-2 boring head. Let's throw it in the mill, check it out. I've actually never used it, so it'll be fun. Alright, let's go ahead and throw this thing in. So, this is, I don't know if I've ever shown before, like the whole process for installing tools in this mill with the TTS system and the spindle lock I made, but I mean it's pretty simple, especially with this tool I made. The smaller side, it's just two 12-point sockets welded to a piece of steel. This side, I think it's a 14mm socket, 12-point. It fits this nut and the nut on the on the vise, and then this side, I think it's 16mm. Fits my drawbar, and it actually also fits all my hold down hardware, at least the big stuff. So the whole process is basically just lock the spindle, tool in, just give it a turn, and unlock the spindle. It's that simple, that quick. So let me pull you in closer. I'll throw piece of metal in the vise and we'll explore how this thing works. Alright, I centered up on this hole, and then I swapped the Wohlhaupter back in and just touched this boring bar off to the top here and then dropped it like 10 thou. So the way this works, the way this differs from a normal boring head, is this ring right here. As the boring head rotates, you can hold this ring stationary either by hand, or there's a rod you can put in here that you can have just butt against the column or hold it by hand as well. And as you hold this stationary, it feeds the slide automatically. I believe it's 2 thousandths per revolution. It feeds across. So let's go ahead and demonstrate that. So the whole thing will spin, and then you just grab, and there it goes. Well, as you can see, the mill was none too happy about that. Alright, I've raised the head up a little bit to get clear of all these burrs that this shitty little boring bar kicked up. So once you've completed your face, your facing cut to whatever diameter you want, you can actually, you don't have to reverse the machine or sit there and hand crank it to get it back to where it started. What you do, now the Wohlhaupter, you know, this would normally come with its own little tool to do this, but a little screwdriver will have to do since I don't have it. Popped out, that's the feed button that's what actually engages it to do what it just did. Now you'll notice that disengages this top ring from the graduated ring. And what you do is there's a little button on top. You push it until it locks in place, and then fire the mill back up and hold the ring. And you can see how far in the hole, or how far inside it automatically goes. It's a rapid return, and then to re-engage, just pop that little button out, and pop the feet button back in. There it goes. So what I was talking about just a second ago with how the rings are decoupled, you can see now with the feed button engaged, you turn the top ring clockwise, or clockwise, and the bottom ring turns counterclockwise. But you can't turn the bottom ring itself. So in that way, like I said, it'll automatically feed itself across. Now you can use this as a normal boring head or a standard boring head. Pop out the feed screw, pop the button down, and it's very, very hard to see. They're kind of faded because this thing is pretty old. But there's graduations all along this ring right here, and then there's a 0 mark in the center of this flat. And each of those marks is a 1/2 thousandth. Or yeah, 1/2 thousandth. You can actually use this as a coarse feed, and then actually even disengage this. Or, well, no, I guess you can't, never mind. So you can use this ring here to set your diameter. This little knob right here locks the slide in place, and you can plunge the boring head down in the same way you would just a standard everyday boring head, and then unlock this, turn however many thousandths you want to go out, and lock it again. This also has, pull this up, a little too high. So you can see this T-slot here, and then this little, I don't know, nub that sticks off. Another thing that this boring head is missing, there's stops. They're just small L-shaped pieces of metal that engage against this when you set them wherever along this T-slot, and when the slide, when it hits the, when the slide moves over and the stop hits this button, it'll actually disengage the feed, and that is adjusted. You can adjust the trip, like how much force it takes to trip the feed off, with this little set screw right in here. And what that'll do, you know, the feed button will be pushed in, and then once the stop engages the trip dog here, that's what it's, trip dog. Whatever spring tension you've set in here will determine when this pops out, and that way you can actually repeatably automatically face to a specific diameter. You have to take a test cut to determine where to set your stops, but once you've got it set, you can take repeated face cuts and end at the same diameter every single time, repeatedly. Another function of that mechanism is that if the cut pressure gets too high, it'll automatically disengage the feed as well to protect whatever gearing is inside. So that's pretty much it for this project. There will be another one where I'll make the stops that go in this T slot, and then there are T bolts actually from the factory that go in these slots with nuts on the outside. I'll have a project in the future where I make those. But for now, that's it. I hope you enjoyed, hope you learned some, and see you on the next project.